Assalamu alaikum. Dear students, my name is Vairavan, and today we are going to start our fifth lecture of artificial intelligence. If you do have any type of question in my previous lecture, if you do have any confusion, you can simply email me on my email, and you can also WhatsApp me if you do have any kind of problem. I will try to reply you. Let's start our today's lecture. This is very important lecture of this course as it is the basic component of artificial intelligence, that is search. So what is search? Dear students, we have some actions that can change the state of the world. State of the world means that if we are working on if we are writing on the page, so as you are writing on the page, the state of the page keeps on changing. Like you have wrote first line, and then you have wrote second line, and then you have wrote then you write third line. So after each line the state of the page will become changed. As this slide right now, this slide is has two lines and one heading, and when I will click my mouse button, now you can see that there are four lines in front of you in this slide. So each action that I will perform from my mouse or from my keypad, that will change the state of the world. So write down, if I am considering this page, so this page is the world. This page is the world. As you can see, this is the whole white page, and all these are due to the actions that I am performing from my mouse. So and every action that I am going to perform with my mouse is changing the state of the world of this page. Now I have pressed my mouse button, and it has displayed me the next line. So this is these are the actions. So change resulting from an acting perfectly predictable. Why we do search? uh, as we are in our daily life, we are always searching for our goal, our destination. So same way, this is the same search that the computer will do. And what is the purpose of this search? Try to come up with a sequence of actions that will lead us to a goal state. So this search is done just because we have to reach the goal state. What is the goal state? The end state of any problem, that is the goal state. We will later on discuss this goal state in detail. May want to minimize number of actions. Yes, definitely. If I want to do any work and that works involves different type of action, it would be my priority that I must reduce the number of actions that are involving in that particular action. More generally, may want to minimize total cost of the action. Cost of the action means that if I want to print out any page from the printer, and I need different type of actions. So first of all, as a user, I would like that system that has less actions. Like I just pick the wire of the printer, and I just plugged into the computer, and I will definitely prefer that it should start working. But we need to have some different steps to install it later on. But all the actions that we are performing to install the printer, that would have a cost. That cost could be of power of the machine, that cost could be of the timing of the machine. So uh, do not need to execute action in real life while searching for solution. Everything perfectly predictable anyway. Yes, this is main theme of this whole slide, that everything perfectly predictable anyway. Anything can be predictable, like we can judge anything perfectly. So, a simple example, traveling on a graph. This is an example of graph, as I already mentioned in the first lecture, that the prerequisite of this artificial intelligence is data structure. And if you do have concepts of graph, that is a data structure. So this is graph. So a graph has the properties that it has some states. This is one state. This it has a name, that is C. This is another state, that is B. This is another state A. So we have different types of states named as A, B, C, D, E, and F. And as you can see, the arrows, arrow-headed, and these are the different edges that are connecting these different types of states. Though, so every state has different types of different weightages. Like if I want to go from C to A, then I have to weight of this edge is 2, and if I want to travel from A to B, then I have weight of this edge is 3. So definitely, if you consider, dear student, this is a city, and these are the different bus stations, and you have to travel in the city from one station to another. So there must be, for suppose one of you student is standing on the state A. So this is the bus station, and you want to travel from A to F. So this, the initial state from where you are starting is the start state, and the end point, that is where you want to go, or that is your destination, that is goal state. So if you start from here you have two options. One, you can go from A to B and B to F. The second option you have is traveling from A to D, and then D to E, and then E to F. So the main thing that I want to explain is that in this particular slide you have the let me draw this diagram for you. Let's see. We have this particular. Okay. Let's see. You are starting from here, and you want to go to your goal state, so you can go simply from here to this state. So this is uh, one way. And if you want to go to final state, you can also go from this way as well. But the one thing that is very considerable, that if you select this way, you have three, weight of this edge is 3, the weight of this edge is 9, and if we add 9 into 3, so that will become 12. So If I travel from this way, my output will be 12, and if I travel from A to F through this way, so let me draw 3, this one plus 4, this one plus 4, this one. So this will become 8. 4 plus 4 is equal to 8, 8 plus 3 is equal to 11. So I will preferably go from this way because the cost of this way is lesser than the cost of from going from A, B to F. So definitely if I'm traveling in the city, I will definitely prefer to go from this way. So these are states. I am revising this. These are the state. This line is edge, and an edge has weight of 3, and this state has a name of B. Okay, let's move on to discover some more topics. Like we have okay, okay, this is a very good explanation that this is the start state. We are going from A to B or D, and if we go to B to, we have two options to go from B to F as well and B to C as well. Then I have another way I can travel from B to C and C to A, and then this is the goal state. Okay. Okay, uh, here we have some more explanation regarding this lecture. Okay, this is good. Okay, this is a search tree. As you have seen in the previous slide, this is, what is this? This is a graph. This is traveling graph. So you have you must have understanding of what is difference between a graph and a tree. So this is a tree of that same situation, same scenario. I'm traveling from A to B, that are the same states, and this has cost 0 because I'm traveling and I have started my journey from here. And if I go from B to F and C, I have cost of 5, and here we have cost of 12, as I already computed in the last slide. Here you can also travel from C to A. This is the goal. This one is the goal, as the slide shows. S- Search tree nodes and state are not the same thing. Okay, search tree nodes and states are not the same thing. You should have this is the search tree, and these are the states. So as I have different I have explained you before that these are the states in the graph. These are the state. C is the state, B is the state, A is the state, D is the state, and F is the state. But if you see here, these all rounds are not the states. So this is all about that you should have the difference of state and a node. This is a state. This is sorry. This is a node. This is node, and the graph has sorry graph has states. So let me repeat again. Search tree nodes. These are the search tree nodes. Remember, these are the search tree nodes, and these are the graph states. So it is the major difference between these two. So this is full tree graph of all the state from where I can move from one place to another, and this was the F state, as we had as computed, the one answer was 11 and the second was 13. So this is full search tree. What do you mean? What I mean to say, this is a full search. Why it is a full search tree? It is a full search tree because it is demonstrating all the world of this problem. Because this tree is contains all the states that I have in the in that problem that I was discussing with the graph. I'm saying about this thing. If I draw a tree from A to F, that would be a search tree. That would be a search tree because it is demonstrating that A is starting point and F is the goal point. But this tree is also showing, this tree is only showing that this is the goal state. But this tree is demonstrating the whole world, that what is the overall problem. So this is demonstrating, this is showing the whole city. Changing the goal, want to visit all vertices of on the graph. Need a different definition of a state. Currently at A, also visited B, C already. Okay, if I say A, B, and C, this is a loop because you can go from A to B and B to C, so this will become a loop. There is another loop that is A to B, B to F, and no, this is not a loop because it's not going backward. This is a loop because you can go from A to B, B to C, and C to A. Large number of states is equal. This is the topic of analysis of algorithm. That if you want to say uh, how many number of states in this graph, n raised to power 2 into n minus 1. N is the number of states raised to power 2 and n minus 1. So this formula is used for finding the total number of trees in this graph. Dear students, there are some key concepts in search that you have to remember. First of all, including an initial state. Uh, if you are searching, so you must have initial state in your problem. If your problem do not have an initial state, that is not that problem would not be considered in search. The second that is very important is goal state, that is the final state. For every state, a set of actions that we can take. Yes, actions should be in your search. Right, action could be that you can travel from one state to another state, from one node to another node. So this could be an action. Each action result in a new state. Whenever you will take any action, whether you are if you are sitting on a chair and you take an action like you raise hand, that will definitely change your posture. And if you are traveling a car and you travel within the city, so after some time your location will be changed, and that will result that you have changed your position. So every action results in a new state, typically defined by successor functions. Given a state, produce all state that can be reached from it. Cost function that determines the cost of each action. Path is equal to sequence of actions. As cost function, as I have previously calculated in our last slide, that we had to go from one place to another one, from one node to another node, and we have calculated the total distance between A to F. So that is the cost function. Path from initial state to a goal state. So this is the solution. So if I conclude this slide, if you are searching in artificial intelligence, your problem should have initial state, your problem should have a goal state, and you should have a cost function, and you have a solution. So solution is the end point on which you reached on the goal state. One thing that is very important in this search is that solution with minimal cost. Like if you are in Lahore and you want to go to Karachi, so the best I'm actually demonstrating or explaining the word optimal. Optimal means best solution. Optimal means best solution of all solutions. If I want to go from Lahore to Karachi, if I first travel to Peshawar and then Peshawar to Karachi, so this is one option. I have one option. And if I simply go from Lahore to Karachi, so this is another option. So what you suggest, what would be the optimal solution, yeah, or optimal path? The optimal path will be the shortest distance between 2 points. So that would be an optimal solution. Dear student, this is the end of your fifth lecture. Hope you have understood all the points that we have discussed in this lecture. We have discussed about solution, about cost function, about the actions and initial state and goal state. These are the concepts of search. If this is a full search tree, changing the goal state, we want to visit all what is on the if we are currently at A and we want to B and C, so every action that we will take will change our state. This is a search tree. This is a full search tree because it is demonstrating the whole world. uh, this is a search tree because it is displaying the initial state and the goal state. This is a graph solution. This is initial state, that is also known as start state, and this is goal state. Simple example, traveling on a graph, state to goal. This is search, and this is all about your fifth lecture. And dear student, I will see you in our next lecture. Till then, Allah Hafiz.